So thank you everybody for joining, and welcome to the Hamina webinar featuring very special guest star Kevin Robinson, the CEO of Wi-Fi Alliance. So yeah, Kevin, how are you? And tell us about you and your retro Wi-Fi installations in suits that you apparently are doing here. So brief round of brief introduction, Kevin, if you don't mind.
So I'm going to go with the American response to "How are you?" not the Finnish one. So we'll not get into the whole 5 minutes. I'm doing well, which is the generic. How are you? No, things are going well. Again, just living the Wi-Fi dream. Getting ready to head out to Europe for our member meeting that's happening in Spain. So super excited about that. Frankly, just been doing a lot of kind of heading around the world, making the case for Wi-Fi, making the case for 6 gigahertz, which is obviously very relevant to what we're going to be talking about today. So just looking forward to the conversation.
And if you look at your day-to-day, like how much time do you actually spend with 6 gigahertz Wi-Fi versus everything else? And what is the everything else bucket? Like how much is what can you tell us about other things that keep you busy besides 6 gigahertz Wi-Fi?
Yeah, so I think from a travel perspective, it's been a lot of 6 gigahertz focused. We're trying to make the case around the world. And we'll get into this a bit in the materials of opening up the full band, which I think is incredibly important for the overall performance benefits you're going to get in Wi-Fi. A lot of the other stuff we're focused on is just how do we make Wi-Fi better? So if people aren't aware, Wi-Fi Alliance, one of the main things we do is we manage something called Wi-Fi Certified, which is traditionally it's focused on interoperability. So you can buy devices from any vendor and they're going to work well together. But increasingly that's clearly critical foundationally. But increasingly we're also looking at things like, what are kind of weird behaviors we're seeing in devices? What are things that are ultimately impacting the experience people are getting out of their Wi-Fi devices? And then how can we evolve Wi-Fi certified to make sure that people are getting a good experience out of Wi-Fi? So it's a lot of things around that, discussing with service providers, what are the challenges they're seeing, the enterprise, the challenges they're seeing, and what Wi-Fi Alliance can ultimately do to make the industry more successful. And the way you do that is you make sure that customers and users of Wi-Fi love Wi-Fi, right?
Talk about important work. And given that Wi-Fi makes the world go round, you guys are a big grease in that wheel, I'd say, at Wi-Fi Alliance. Jerry, how are you, my friend? Thank you for joining.
Yeah, thank you. Doing very well.
And Joel, also welcome. I did not have you on the I wasn't aware you're coming, but thank you for joining, and thank you for already grabbing the chat. So much appreciated.
Of course, happy to.
And so together with Joel and Jerry, we kind of represent the janitorial services at Hamina. We make all kinds of Wi-Fi products and things. And if you're on LinkedIn, feel free to snag a picture if you're into Wi-Fi geek outposts and things like that. And feel free to connect with us there as well. And yeah, so just quickly about the relevance, why are we here? So Wi-Fi Alliance Services and Hamina, we've been working on this partnership essentially where because 6 gigahertz Wi-Fi outdoors requires a little bit of regulatory compliance from, or we need to obey, the Wi-Fi APs need to obey whatever the AFC service tells them. Kevin will actually talk about that. So we created an integrated solution which is now shipping, or is shipping next week, actually, against the Wi-Fi Alliance production AFC database. Hamina Network Planner Plus tool work together to enable you to design and deploy good quality and regulatorily sane networks, if you will. We'll take a look at the demos and kind of look at different aspects of 6 gigahertz design outdoors and indoors later as well. But the idea is that Wi-Fi Alliance Technical Services Hamina partnership is what has brought us together. But yeah, over to you, Kevin, if you don't mind us taking us through the whole 6 gigahertz Wi-Fi dilemma, because there's first of all, there's a lot of this is such a big deal. People don't know how big of a deal it is. And secondly, it's kind of a living, breathing thing still. You know, it's a different animal in the States and in Europe, and it's molding all the time. So take it away, Kevin. First of all, thank you again so much for joining, and let's jump right into it.
Absolutely. It's a pleasure to be here, and hopefully my screen is sharing.
Yes, sir.
And while that's going up, I guess just one other kind of clarification here. So what I'm presenting, the first piece I'm going to be presenting on is really from the broader Wi-Fi Alliance perspective. So, you know, Wi-Fi Alliance Services is a subsidiary of Wi-Fi Alliance, specifically focused on delivering automated frequency coordination for device vendors, people like Hamina, et cetera. But, you know, just as most importantly, I also have the hat of being the CEO of Wi-Fi Alliance, and, you know, standard power is something that's going to benefit huge numbers of vendors, whether they be device vendors. There are other AFC operators out of the market. You know, it's like your federated wirelesses, your CommScopes, Qualcomms, et cetera. So I think, like much of the Wi-Fi industry, there's a vibrant, diverse ecosystem, which I think ultimately is what helps drive, what drives our success, because people do have that choice. But as you said, you want to get into just some of the Wi-Fi Alliance perspectives on 6 gigahertz standard power, which we really view as the next frontier for Wi-Fi. Okay, so this is kind of a pretty key picture for people, and this is looking at what is happening in global regulation around 6 gigahertz Wi-Fi and 6 gigahertz Wi-Fi generally, not just standard power. So you see kind of more of the teal colors there. Those are the countries that have already opened up the full 1200 megahertz of 6 gigahertz spectrum. Okay, so what does that practically mean? So in the US, that opened up an additional 7 160 megahertz channels. You add to that the roughly 3 and 5 gigahertz, and you have 10 channels of 160 megahertz Wi-Fi, which, if you're looking at denser deployments, things like enterprises, things like sports stadiums, a lot of, one of the critical pieces is not just how fast can any one channel, how wide a channel can you get, how fast can you get data across that channel, but it's, do you have enough diversity of channels to plan robust high performance networks? And so in the US, for example, you're going to get 10 160 megahertz channels, which make those wider channel widths feasible in a lot of these deployment scenarios. Then you look at, let's say, Europe. So Europe has opened up the lower part of the band, and they are still considering the upper portion of the band. And that's part of what's driven a lot of my travel to Europe recently, is how do we really make the case for, one, Wi-Fi as a technology? Because of course there are other interests that would like that upper portion of the band. But we think from a societal benefit perspective, Wi-Fi is really the best allocation of the spectrum, and we can share it with incumbents, so they don't have to push people out of the band. But in terms of where Wi-Fi is right now in Europe, in most of these locations at the lower portion of the band, that gets us 3 additional 160 megahertz channels. So for a total of 5, up to 5 in many of these countries, which start presenting challenges as you're planning, right? You may not have enough frequency, channel reuse for a robust deployment, just depending on the environment. And so that is one of the channels. So in many cases, you might then be pushing down into 80 megahertz channels to get enough spectral diversity. And then we have other regions of the world which have not opened up any 6 gigahertz. But I think for most people, the expectation is that as Europe starts to solidify their rules, you're going to start seeing other companies looking to either the model of the US or Europe, and then using one of those models going forward. But I think some companies are taking a bit of more of a wait and see approach on that. Okay, what's happening with 6 gigahertz? Projections are very ambitious and very encouraging, I would say. Wi-Fi 7, if people, most of your audience probably knows this, but Wi-Fi 7 was the first generation that kind of natively was built on the availability of 6 gigahertz. So we added 6 gigahertz into Wi-Fi 6, called it Wi-Fi 6E, because it kind of came in midway between generations. We thought it was so valuable that we wanted to get it out there early. But Wi-Fi 7 has always kind of understood that 6 gigahertz was a key piece of the value proposition. It's part of what drives things like MLO, where you can, have links in two different bands, driving down latency, et cetera. So that's why you see kind of this inflection point and this acceleration of 6 gigahertz adoption around Wi-Fi 7. If you look here, we're going to surpass, I guess in 2025, we're going to be over 1 billion 6 gigahertz devices shipped annually. I think it's 2027 is an important milestone because that's where we will actually surpass 50% of all Wi-Fi device shipments will be devices that support 6 gigahertz. So if you're a network planner and you're thinking about, okay, when do I really need support for 6 gigahertz? And you're thinking about, you're not that far out yet, right? Where half of all devices are going to have this that are shipping, but especially when you consider, the RFP process and the planning process and the installation process, right? You start backing that out from 2027, and it's not that far off where I think 6 gigahertz is really going to be essential for the majority of deployment scenarios. So where do we see standard power early on? Definitely outdoor connectivity. And part of the reason for that is, and I'll get into some of the detail, but 6 gigahertz indoor is available today. It's called LPI, low power indoor, does not require an AFC. But all outdoor deployment requires an AFC, which, even though it's kind of a misnomer, standard power, there's two aspects to it. There is the aspect of being able to transmit at higher power levels. And then there is the ability to transmit outdoors at any power level, right? So it's not just about standard power. So when you see outdoor venues, think of a stadium that has an open dome, you're going to need standard power to operate in 6 gigahertz, which means you need AFC. We're seeing a lot of this in the US. A lot of the deployments are in things like, amusement parks, outdoor sporting venues, et cetera. And that's really what's driving a lot of the adoption. So you'll see it a lot on universities. It makes sense. They have connectivity in their sports areas. They also have connectivity between campus buildings. And in order to do that, you really need AFC. Okay, so as I mentioned, standard power 6 gigahertz requires AFC, and it opens a number of different use cases. Things like AR, VR, where you need those wider channels. A bit of an aside here, the Alliance is doing a really cool demo and trial in Thailand right now about the medical usage of VR headsets to train new medical students, right? And these wider channel widths become increasingly important to deliver that type of experience where you have 100 students that might have VR headsets on, right? So a very demanding use case, as well as more industrial IoT, things like that. So what has the Alliance been doing? Kind of our typical type of work. We've been developing specifications, testing around ensuring that these devices work well. And a key piece of that is, as I get into, if you think of that map I just showed, there's a lot of different rules. There's a lot of different device classes. So there's a lot of complexity in how you deliver 6 gigahertz in a device. So Wi-Fi certified in the testing we're doing is important to make sure these devices that are, you're buying them in the US, you're taking them to Europe, you're taking them to Asia. How do you make sure that all this stuff works seamlessly like Wi-Fi does today, when you have a more complicated scenario that's kind of being imposed on us through the various rules around 6 gigahertz. So AFC and standard power is here today. There are devices that are out in the market. There are deployments operating as we speak on a number of different AFC providers. And that really started in February when the FCC approved a number of different AFC operators. We also are starting to see, hopefully we're on the cusp of some additional operators being made available in Canada through the ISED process. I think we're at the very tail end of that. And then again, just dealing on this, Wi-Fi Alliance just continues to deliver value and tools to the industry to make sure that we can ship these products in a cost-effective and in a timely way to make sure we can get to market. Okay, so here's what we have. Let's just look at the two regions where we actually have standard power operating. And that would be in Canada and in the US. Canada only has one AFC operator currently, but like I said, you should expect seeing some additional operators coming online very shortly. Canada actually has a full 950 megahertz of the 1200 that can be used for standard power, meaning outdoor or at the higher power levels. The US has 850 megahertz of the total 1200 usage for standard power. And you can see there's this notch out in the middle that is not available for standard power. Okay, what's going on in the rest of the world? So there is momentum happening in other regions around enabling standard power or dynamic spectrum access. So the EU is one of the biggest ones in terms of the size of the market, obviously. And so there's some work going on right now. There's a work item happening in Europe where they're studying use of AFC to enable higher power levels. We've had demos and trials happening in Kingdom of Saudi Arabia, demos happening in South Korea around the use of AFC for devices. So that again, EU, South Korea, some big markets there. And then of course, Ofcom is also studying feasibility around AFC. And then Japan is doing a consultation right now around operations in 6 gigahertz under control of AFC. And then finally, Colombia has done a consultation as well. So, even though we really, at the moment, we only have US and Canada, I think we expect that you're going to start to see more momentum in some of these other markets. And I think the more each market opens up, I think the hope is that other regulators aren't going to try and invent something entirely new, but they're likely to look at one of the existing models. So we hope that that's kind of like this cycle of the pace just really speeds up faster and faster because you're not having to redo a lot of the same work. It's simply, hey, such and such a country has a model that's very close to what we would need. Let's match that as closely as we can, right? So that's, I think, part of the expectation going forward.
Hey, Kevin,
Yeah.
and I'm sure you were afraid that this question will come, but out of these new major markets, is there any rough ballparks you could give for some of these, like Ofcom, EU, that kind of stuff? I'm sure you never get asked this question, and
it's the first time I've been asked this actually. So thank you for that. And I would say the other thing is it's the question you love, because if you could find somebody who could actually accurately predict regulatory timelines, like I would love to have them right now. Like it's incredibly difficult to predict these timelines. I would say in general, I think we're hoping to see some good progress both in member states and in the EU in general to get more clarity on 6 gigahertz by like next summer, right? So I think those are some reasonable timelines that people are targeting. That's not specifically on AFC, but we have certainly made the case that prolonging these decisions are ultimately undermining the benefits that people are going to get out of 6 gigahertz, in general, and out of Wi-Fi. Today, because we have 6 gigahertz in many areas. Today, if you buy, let's say, an iPhone that has 6 gigahertz and it's going into Europe, that device has the capability to operate across the entire band. It's built in. The cost is essentially already baked into the manufacturer of that device, and it's simply a switch that, for regulatory approval reasons, it has turned off the upper portion of the band because it's not yet available.
Yeah.
So you're buying the device, you're probably paying the same thing I'm paying for the device, right? But that piece is essentially not enabled when it's going to Europe. And so, at the end of the day, the delay, which I think impacts Wi-Fi more than the other technologies that frankly aren't even ready to operate in the upper part of the band yet, and probably won't be for a decade or more. It's probably not a good way to approach setting these policies. So we're certainly kind of pressing with a sense of urgency. Regulators will do what they're going to do, and they have to be deliberate about their decision making. But we think that next summer should be a fairly reasonable target, if not sooner, to have some clarity on some of these decisions.
All right, that's fair. So next
And so
summer.
now I'll be proven totally wrong in like 5 minutes. Something will happen and it'll be like, oh my gosh, like why did Kevin say that? Like he was so far off, but it goes with the territory.
All good, and totally understand. And you know, these things take time, but yeah.
But no, great question. And I know I'm just kind of going, UC, so jump in and interrupt me at any point if there's questions from the audience. So, okay, this is kind of the very high level overview of regulatory differences in the US between low power indoor, which does not require AFC, and standard power, which gives you higher power levels indoors, as well as I said, all operation outdoor requires this. So a bunch of numbers, but what are some things that I would kind of highlight around this? A couple things. The first one is, of course, any outdoor operation, you need standard power, you need AFC. So any use case, again, open dome, sports venue, you need to have standard power. The other piece I'll highlight is, you know, because some of this you can kind of squint and say, well, some of the maximum power numbers are not all that different. Like, you know, why am I getting value out of standard power and AFC? And what I'll point to there is the limits around the power spectral density start really having implications here. So even though, let's say at 320 megahertz wide channels, you can get power levels getting closer to what's available in standard power. The reality is, you know, in the enterprise, you might be using 160 megahertz channels, you might be using 80 megahertz channels. You know, I know in some of these very dense deployments, they want to have upwards of 15 non-overlapping channels for effective planning in like a bowl of a stadium. So now you're using smaller channel widths. And because of that limitation on the power spectral density, that starts really capping the powers you can transmit at, right? So that's one important consideration coming out of this. The other important consideration is the asymmetry in power levels between what the access point can do and what the client can do. So you notice that there's a 6 dB reduction in power limits for the client device versus the access point. And so you have that asymmetry to where, you know, the client's likely going to get that traffic and be able to receive that transmission, but maybe depending on the environment, there's some challenges in the AP hearing the transmission of the client. So what AFC and standard power can allow you to do is, while the client still has to be 6 dB below the regulatory allowable power limit, as long as it's 6 dB below, you could actually have kind of asymmetric power levels. So let's say an AFC returns and it says, okay, you can operate at 24 dBm. That means that the client would have to be at 18, but the AP could be at 18. So that's maybe a good power level, and you have that asymmetric transmission. Whereas with LPI, you're maybe having to be further, you're having to be lower in terms of power, just depending on the channel widths you have. So it gets you a lot more flexibility in how you're planning and what you can ultimately deliver in terms of performance. And some of the scenarios we see this, I think a lot of people talk about, maybe even in the early days, it's not so much for the enterprise environment, but you could still have wireless backhaul, right? Where maybe it's not even the access network providing connectivity to the clients, but if you're doing that fixed, more of a point-to-point link from one AP to another, if you're trying to get out, let's say in the enterprise environment, you have an AP sitting on a pole somewhere, you're able to do those higher power levels for that particular connection, even if maybe the client doesn't necessarily need that higher power. But it's all about providing tools to the network planner and designer that they can operate at the power levels they're typically accustomed to doing their planning. Let's see. Yep. So the next couple slides I'll hit briefly. For those of you who don't know how, like, kind of the nuts and bolts of what AFC is about, this is, the high level what it is. So fundamentally, 6 gigahertz, they're incumbents. There's a lot of fixed microwave links point to point. In the US, that might be utility, utility networks, things like that. It could be, microwave to a cell tower. You also have mobile news gathering, and that's actually one of the reasons you have a cutout in the US in terms of outdoor operation. So these are critical services that have to still happen. So Wi-Fi, the nice thing about us is we can actually operate around these incumbents and still protect them. So that's really what AFC is about. It's letting Wi-Fi into the band while still protecting incumbents. So what happens is, and this is an example, just looking at a fixed point, point-to-point link microwave. Again, this could be utility to an electric grid, let's say. And what we're doing essentially is we're just calculating exclusion zones to where we do not have Wi-Fi devices operating in the beam of the antenna in a way that could degrade the operation of that incumbent who has paid for or been issued a license for that spectrum. So there's various contours that the AFC calculates. At the end of the day, what it spits out is a list of permissible operating frequencies and the power levels. So it's not a black and white, you have the channel, you don't. It's to the level of, these are the channels you could perhaps operate at full power. Here, these are other channels that maybe you have to operate at a slightly lower power level. And these are channels that you just simply cannot operate in, right? So it gives you that flexibility. So what do you need to make that happen? Well, ultimately, the devices have to know their geolocation. There's different mechanisms that you see in devices to do this. You might have some devices that actually have a GNSS chip, particularly outdoor. This makes a lot of sense. They get a very precise location. In other cases, you'll see things like the use of an application on a smartphone. This is more, let's say, for a residential indoor application. You've got the AP vendor's app, and it can actually leverage all of the geolocation capabilities in that smartphone, and then the distance to the residential AP to give the AP an idea of where it is. But at the end of the day, however you do it, also using things like barometric pressure for altitude, that access point has to know where it is. That is a requirement. Once the AP knows where it is, it sends that information into the AFC operator. This calculation happens, and then the spectrum availability gets pushed back out to the AP. That has to happen every day, right? Because it is certainly possible that a new fixed link could pop up, a license could be issued, et cetera. Also, certainly possible somebody could move. So any movement of the AP, like cycling the power, goes through this process again to make sure that it is in fact where that device was intended to be. So that is high level what happens. It's similar to what you would have in like CBRS in the US. But the nice thing is standard power in 6 gigahertz is far less complicated. We don't have the sensing requirements that you have in CBRS. So it really is designed to meet kind of the economics of the Wi-Fi industry model so that you can have this type of capability even in your standard residential AP and certainly in enterprise access points, right? So again, very, very appropriate technology and model that was deployed. So kind of that's the high level overview. I'm sure there's some questions, and just love to have a conversation with UCU and the team and everyone who joined.
Yeah, absolutely. And right here, maybe let's ask Joel and Jerry, like what's going on in the chat side of things. Any common questions, any burning topics there? I see there's been we're in good company. At least I saw discussion between Dave Wright, Keith Parsons. Joel, how's the chat been going? Thank you for moderating.
So I'm interested to hear where Dave is with whatever chat he sent in.
Yeah, I'm just scanning through right now. I mean, there's been a whole bunch of discussion in here, all parallel to Kevin's presentation. And Kevin, thank you for this. This is really, really good stuff. But I mean, we could even just go through the Q&A. There's a bunch of questions in the Q&A right now. And by the way, anybody listening, if you have a question for Kevin or any of us, please go ahead and throw it in the Q&A, and we'll try to get all those answered. One of the early ones that came in from Harry was, what about like ships and vessels? Like, do they need AFC? I don't, man, that I feel like that's a pretty there's a lot maybe inside that question to unpack. Any thoughts on that, Kevin?
I'll have some thoughts, and I'll preface it with I am certainly not the regulatory expert. We have Alex Roitblot, great resource, and knows all the ins and outs of all this stuff. Has been on the delegation at WRC, et cetera. But what I would say with vessels, so obviously the rules in terms of standard power for the US, that is within the US regulatory domain, right? So, for example, in AFC, if you have a device that is out off the coast and is not within the region, let's say, that is covered or allowed by FCC rules, let's say, they would get a response that essentially says unauthorized, right? So, the device has to be within the jurisdiction of the FCC and within the sets of rules.
So it sounds to me like the device is going to default to no, I'm not going to transmit unless I explicitly get permission to transmit.
Well, certainly for standard power, that is always the default.
Mhm.
So a standard power access point cannot transmit until it gets explicit permission based on the location that's been submitted in. It's not something like where it can just start transmitting and eventually check in and fix things. No, it's because again, the incumbents here are critical infrastructure, and so it's imperative that those devices are not, interfering without first checking with that they are not interfering, period. And in order to do that, they have to check in with the FC.
Mhm, mhm. Gotcha. Another question that came in that I was curious about as well is LU asked, what's the difference between EIRP and EIRP density? I saw that on one of your previous slides. I think it was the orange one had a table.
Yeah, let's see if we can find that really quick.
There we go. That's it.
Yep, exactly. So, essentially what it means is there's two components. There's just the overall maximum transmit power, right? And no matter what the density is, you cannot exceed that. Now, where the density comes in, and you see there's something here, let's use the example maybe of low power indoor, -1 dBm per megahertz. So the calculation is going to look at the power per megahertz. And this is what I was saying. So if you have a 160 megahertz channel or even a 320 megahertz channel, maybe I'll use that 320. So a 320 megahertz channel using the spectral power density, that would allow you to transmit at essentially the max EIRP. But what happens is, as you go down to 160 megahertz channels, 80 megahertz channels, 40 megahertz channels, now you start getting limited by the power spectral density. So you may only be able to transmit at these smaller channel widths at 10 dBm, 15 dBm, right? It depends on the and this it's gonna challenge me remembering all my log base 10 and all that of swapping between the two. But essentially, you are limited by the density of the power. So if you're narrowband, your power density is greater, meaning you're going to be capped. They're going to have to actually reduce your total power transmit power level.
Excellent. Should we take a look at a couple of examples of 6 gigahertz design and featuring AFC and stuff like that? So
I think it's a great idea. I think it'll make it a lot more real when people kind of see how this actually plays out in a real deployment scenario.
Okay, so let's actually first start indoors, where if you're not using standard power. So this is maybe this is today's case, right? Is pretty much like low power indoor and no AFC needed. So you don't really need to worry about it too much. But what you do need to worry about, and what becomes more and more apparent, for example, in Wi-Fi 7 especially, is channel widths, right? So I'll just put in all the channel widths available, including the 320. And where was this university now? So this is in the US. So we actually have plenty of room on the 6 gigahertz band. So we have what 320 megahertz channels in the US. In Europe, we would only have one. But let's see how that goes. So as we start the network design, we can see well, actually on 6 gig we're already using actually 160s. It seems like maybe the tool doesn't even give us. But observe this guy here. So 6 gigahertz on 160, 5 gigahertz on 80. And as we start deploying more and more radios near one another, and I should really scroll up the screen. So let's look at that. As we start deploying more and more, you will at some point start to see channel interference, and you do need to worry about that, of course. So
you know, see the 9166 only goes up to 160 megahertz channels. So yeah, that's one thing to consider as well.
No wonder. And now we can see, for example, 5 gigahertz channel width was changed to 40 megahertz. So still, I guess on 6 gigahertz, we're still rocking 160s, but now 6 gigahertz was changed to 80 megahertz as well. So the more dense your network design, the more you might want to push down on the channel widths. And right now, we're still allowing a little bit of interference in some cases. So even if the tool does optimize its way around them, but if it starts to see too much interference on 5 gigahertz or 6 gigahertz, it will fall back to like here we can see it did not still fall back. We're looking at 6 gigahertz. It's still at 80 megahertz. And this is what I like, you know, you do actually, I'd rather prefer a little bit of channel interference over having to reduce the channel widths immediately. So this can be configured, but I do like to configure it so that, you know, allow a little bit of channel interference. But in the US, this is supposed to say I usually design with European projects, and like the fallback of the channel starts to happen very, very quickly. So the connection gets a lot slower or a lot more quickly because we have less than half of the available 6 gigahertz spectrum compared to the US. And what's happening behind the scenes, if we look at the, let's look at the channel numbers. So what's happening behind the scenes is the channels are optimized. Every time I place a radio, it's kind of like 2.4, 5, and 6. I have 2.4 disabled, but this kind of reruns the radio resource management algorithm every time I make a change to the network, and then reduces the channel width when it sees a need for it. But what's great about the US, you know, the enormous amount of spectrum on the 6 gigahertz side of things, we're still, no matter how many APs we place, we're still on 40 megahertz on the 6 gigahertz band. So for indoors, you know, that's how it goes, and you don't really have to worry about AFC, right? If you're not doing standard power, which I would guess, Kevin, am I right? Like, people generally do not do standard power indoors yet. Is that a fair statement for the most part?
I would say that the certainly the earlier deployments are more outdoor, but you are absolutely going to be seeing standard power indoor, including in residential APs.
Excellent, excellent.
Yep.
And so let's move into the AFC and outdoor territory. So let's say this area is outdoor somewhere in the States, and I'll just clean it up. How about that? And what needs to happen first if you're doing a Wi-Fi network design? You kind of the regulatory or geographical location is pretty important, right? Because the AFC restrictions can vary quite a bit depending on the location. Isn't that right, Kevin? Like if you have incumbents, you know, nearby, you will be more restricted on the power levels provided to you by the AFC, right? So if you're near a tower, there's a good chance you have less power at your 6 gigahertz outdoor in your 6 gigahertz outdoor network. Is that fair to say?
Yeah, absolutely fair to say. It completely depends on kind of the density of the incumbents that are in the area, but you know that's going to have an impact. So you'll see some urban areas just happen to have a lot of fixed links, and so this can have an impact.
Absolutely. And let's deploy a few few APs here and there, just align them a little bit, and now as I kind of release my mouse, we can see new AFC request was sent. So now, this is where we connect the Wi-Fi Alliance services database, and we retrieve the amount of channel, like the power levels that are at our disposal at this time. And when we get a response, the system automatically configures around those restrictions. And if we have too high of a power level, then we disable or we do not use those channels. We actually use other channels. And if the power level is way too high, then we just don't utilize any channel stuff like that. And this is where we can take a little bit of a peek. Now that we got a response from the AFC system, we get a peek behind the scenes. So we can see these are the channels on the x-axis for the 6 gigahertz, and these are the APs that we deployed. So clearly they are on 80 megahertz since they eat 4 channels, and we can see the AFC limits as well as the EIRP of these radios in question. Then we can also see the number of radios per channel. And we can also see power spectral densities that are allowed for each of the APs. And let's take another project like let's take the Michigan Stadium, okay? So here we have a couple of APs. This goes to say about the geographical differences. Let's look at this. See, we have blue APs on this side of the stadium. We have red APs on this side of the stadium, all right? And let's look at the difference between blue and red APs from the AFC. So again, what we got from AFC overall, but let's look at power spectral density and how the AFC kind of gave us the restrictions. And observe, for example, 6200 megahertz around here, how different the AFC allowed power levels are. We're in the same stadium, just different ends of the same stadium, and still we have like what 10 dB difference in the allowed power levels on this channel from the AFC service. So then, granted, this is like probably is this it might be at a reasonable distance to a tower or something like that, but yeah, there's definitely differences, and this is why the geographical location matters. And this is why, for you Hamina users out there, how you actually place your design on a map. Let's say if it's a university campus, if it's a stadium, if it's an outdoor like city area, if it's a port, marina, stuff like that, you use our coordinate tool. So you place two of these coordinate things on your map. Essentially, what I did here is I just copy and pasted coordinates from Google Earth. Just right-click anywhere on Google Maps and say, pick the coordinate, and it copies on your clipboard, and then just paste it on the Hamina coordinate tool. Do that 2 times, and your AFC system is kind of initiated. And then whenever you start placing 6 gigahertz APs on that map where you have those coordinates, you will see that taking the impact. You will see the AFC button here if the system is initialized correctly, and you can not only will the system work its way around the restrictions, it will also show you what's going on, and it will reduce the channel width accordingly and all of that. So that's kind of the power of the combined solution. So whenever you make changes to the network, we contact the AFC services, the Wi-Fi Alliance services database, and ask like, hey, for these access points, what can we expect in terms of power levels, given that these access points are in these geographical locations? Is that a fair summary, Kevin?
Yeah, absolutely. And I think particularly when we looked at some of the challenges that the industry might have around this, is obviously the access points they're going to have to independently talk to an AFC to get authorized to use the spectrum. But so many people we had talked to when they're looking at, well, how do I know whether to make the investments on standard power devices, or what's it going to look like in this particular facility with standard power availability? And this lets them see all that, right? So they know it's like, okay, yeah, so I have an issue with this one channel. Well, I can now plan around that. And so I think it's incredibly important to kind of facilitating the adoption and the rollout of these types of networks for something that's fairly new, I think, for most network planners. They've never had these challenges of dealing with something that's a little bit more of a dynamic scenario in frequency availability.
Absolutely, absolutely. And it's like, to me, it's not necessarily even just like in indoor deployments, like RRM will usually take over, and the decision, the end decisions are made by the infrastructure. But just like in indoor deployments here also, we give you an understanding, like you said, Kevin, of like what is the availability, how wide of channels can I expect to use, and how many of those channels do I have available before I run out of spectrum reuse, and thus I can also predict the performance and the capacity of my network. Like here's another example, like near the United Nations headquarters in New York. Again, red access points on the right, blue access points on the left here in the park on the poles. And we can see like what a drastic difference in terms of power availability. The blue guys are actually in the park are having quite a good day, but the red guys are quite restricted in terms of power levels on the right-hand side. So this is, it makes sense to do this. And I did not deliberately search for this example. I just took like a building I happen to know in America. So this goes to also, like my general knowledge is poor, obviously, because I know two buildings in America, the White House and the UN headquarters. So I picked one of the two that I know.
Hey, UC, there's a question or comment from Kevin in the chat, Kevin Franzen. By the way, Kevin Robinson, Kevin Franzen says you have a great name. So,
likewise.
Probably referring to his last name, Robinson.
Of course. So yeah, Franzen's question was, hey, UC, during the outdoor design phase, how do you know what channels you can use for each AP? Because there's no AFC connection or channel assignments from the AFC yet. How do you know that? How is that showing up in your tool? What's going on there?
Yeah. Well, that's exactly right. That's exactly right. We query first, and of course initially we don't, right? We have to query like the AFC database for this location. What do we have for availability? And the raw response is really something like this. So for a single AP, like this is the raw response that we get from the Wi-Fi Alliance Services AFC. And then, we tell the AP like, okay, first of all, you have to live by these power limits. Secondly, we start like organizing the AP channels so that the APs are having a good day and they're living, by these. And then if need be, we also reduce the channel width so that, interference is minimized as well.
But you see, I think the key thing that I think comes out of that though is, this is real AFC data, right? So these are the exact same calculations that an access point would have done for an AP in the field.
Exactly.
Now clearly there's no like regulatory authorization that comes with this, but it's the same data, right? It's the same responses an AP would get.
Exactly. That's well said. We use the same friggin' API as all the APs use for this. And in fact, thank you, Kevin, and your team for kind of, helping us out and improving the API, to meet the needs of also a wireless planning tool. So this is indeed the same service. It is the same API as the APs tap into.
Yeah, that's the beauty of this, I think, is before you even order the equipment, start building out the infrastructure or anything like that, you can have an idea of, what the APs are going to see before you ever get near that point or expense.
Exactly right. Any other questions from the audience? Jim Florwick from Cisco is saying, I show this to anyone planning AFC. Great tool. Thank you, Jim, and thank you for helping out, building this toolkit. So thanks to you as well. Anything else?
I think the other thing to kind of think about with this that we're not really talking about is, the 5 gigahertz side, right? In the past, we had 5 gigahertz, but we had no visibility until you did a truck roll or something like that to go on site to actually see what's available in the spectrum, how saturated that spectrum is. is that something that we can kind of leverage this AFC database to provide us a lot of insights to see maybe how saturated the spectrum is to some extent before we get on site? I don't know. I'm kind of thinking that through as I'm kind of saying it, but yeah, I'm just wondering, like, can we use this AFC database and this information in comparison to what we haven't had visibility to before to give us some insights and some availability to the spectrum on the 6 gigahertz side?
So what you're asking is, do we also get some kind of channel utilization information, for example,
well, more can we read between the lines, right? If we see that there's lots of channels and power available to us, that should give us some indication that there isn't a lot of other devices that are utilizing those channels and that part of the 6 gigahertz spectrum, kind of get an idea from a capacity planning standpoint, you know, how much spectrum is actually available to us without even having to do, you know, a site survey or anything like that, you know, actually go to that physical location.
But this only accounts, correct me, Kevin, if I'm wrong, but this only accounts the incumbent links and things like that. It doesn't account for the true spectrum utilization.
Correct. And again, don't quote this, and I know Dave's in the audience. Maybe he definitely can correct me, but my understanding with something like CBRS, they are actually also having to look at aggregate interference based on the number of other devices that might be transmitting there, I recall. But the main point I'd want to make, though, is with AFC, none of that is happening. So the AFC operator does not have some list, let's say, of devices that happen to be Wi-Fi devices that are deployed in that area to then say, okay, we already get this other interference, not only from the incumbent, but also from deployed Wi-Fi devices. That's not part of this. This is truly just authorization to use the spectrum based on the impacts to incumbents.
Exactly. And by the way, I did allow Dave Wright to talk if he's here. Dave, it is good to see you. Would you mind introducing yourself and then telling us how the lay of the land truly is?
Oh, wow. Thank you. See, I don't want to take much time, but yeah, Dave Wright worked in regulatory policy advocacy for Ruckus, then Hewlett Packard Enterprise Aruba for quite a while, worked closely with Cisco and other enterprise vendors and getting 6 gigahertz opened up. Yeah, retired about a year ago and now doing a little bit of consulting.
Congratulations. So yeah, what's your take on AFC and any additional points we should bring, or anything you'd like to anything you know would like to add?
Oh, I don't want to co-opt your show.
No, dude.
That's how they operate
the
around
show.
here, Dave.
To a certain extent, I'm still getting my feet back underneath me too. So I'm sure you, Kevin, are much better informed on the state of play than I am. But I mean, one thing I will say, you know, to some of the points that have been coming up in the chat is, you know, I think for those countries who really want to be serious about standard power, both for outdoor and then for indoor higher power. And I was noticing Jim's comment about Bell, and yeah, I was working really hard to get the FCC to let us take Bell into account. But you know, I think it's going to be hard if you've only got 480 megahertz as your starting point to get enough wide channels, you know, at standard power to you know, in some cases make it worthwhile for a stadium for sure, right? So so I think it's a good argument that we need full 1200 for AFC and standard power.
Sure.
Yeah, and actually, if I could add on one point, because I did notice the chat come across around Bell. For those who are not familiar, it's the building entry loss. So when you're doing indoor calculations, so again, a standard power device, but indoors, the way it is today is the AFC operators and the AFC systems are not allowed to take into account the fact that you're going to have entry loss, building entry loss from the incumbent transmission going through, you know, the brick, you know, I've got energy efficient windows and all that kind of going into the building. So you're essentially acting as if that indoor access point is sitting out in the open with no building around it, which of course is not true for an indoor device. There is the industry, multiple operators, and of course the Wi-Fi Alliance has been very much pushing the FCC on this, but there is a waiver request that is actually in the FCC as we speak it's been under consideration for some time, that would allow AFC operators to take into account building entry loss. If that waiver is granted, which we certainly expect and hope that it will be, because an LPI device, a low power indoor device, they get to take advantage of building entry loss. So why does that device get to consider it, but the AFCs are not allowed to consider it? So logically, it makes sense, right? But again, we hope the FCC will grant the waiver on Bell. And if that happens, then even an indoor device, which doesn't necessarily have to use AFC, it can use LPI, but they're going to be able to get higher transmit power levels by using an AFC, because they can say, okay, there's no incumbents here. I know I'm indoors. I've got building entry loss. Give us that additional margin, if you will, that additional budget for power, because we know we're not going to be impacting the incumbents.
And how much is the Bell typically like? Do you remember, or does Dave remember, or does Jim Florwick remember?
I should know. I should know this.
Is 10 dB?
Yeah, it's in dBm, but I'm trying to remember what the value is.
Jim says I understood 6 dB. Okay, so that's very.
I think it is.
It's pretty conservative, right. But yeah. sounds about right, like brick wallish type of attenuation. That's really good. So in terms and we left out, like, for example, from a tool vendor's perspective, we left out indoor AFC standard power from the first version. And we talked about this with Kevin when we were starting up and your team. And we were like, okay, outdoor is the first thing. And let's keep things simple, get something out the door. So as we start moving into indoor standard power, besides Bell, what do we need to worry about? Like which floor is it on and this kind of stuff? And how complex does it get for the for us and the AP manufacturers?
Sure. So the tool vendor and the AP vendor, you don't have to worry about Bell, because the AFC is ultimately, if the waiver is granted, the AFC is going to incorporate that into the calculation. Okay. So again, whatever you get, your live data is going to take into account that building entry loss. Okay. The key thing for the AFC vendor is obviously the device has to be indoors, right? So it can either be indoor by rule, meaning that when you look at LPI, there's elements to the rules that say, it's got to be mains powered, it has to be plugged in, it cannot be weatherized. So there's a number of attributes that by rule say this is an indoor device. So if the device indicates to the AFC that it is indoors, then it will get that additional power increase, because the calculation will take into account Bell.
Okay, and is that it? Like no floors considered, like how high it is and
well, it does, because the geolocation takes into account the altitude, right?
Yeah,
so
that's right.
All that factors in. So people will be using things like barometric, calibrated barometric pressure to get a more precise altitude on the devices. Another option is professionally installed, right? So if somebody is putting it in, they can essentially configure the device to say where it is, where the altitude is, and then that. But ultimately, that is a configuration of the AP. But then the AP has to provide that to the AFC to get the authorization.
Oh, okay.
But the same thing, your tool UCA would say, here's my altitude. That would come into the AFC, and then you get a response.
Exactly. So we would just calculate like which floor it is on, take into account the floor height and stuff like that. So easy for us. Okay, that's great. That's great. We are pretty much at time, and Kevin, I think I probably told you like it's gonna take 30, maximum 45 minutes, and here we are at 60 minutes. So much appreciate your time, and we're already getting like smashing good feedback on the chat. So definitely you hit the main points, and thank you Dave Wright and Jim Florwick and everybody for chipping in as well and making this truly one of the great webinars we've hosted. Joel, Jerry, any closing words?
Yeah, from my side, just I learned a lot, so I was really looking forward to this webinar, because the whole AFC and standard power and everything is still such a new concept to us, even though I've been in the Wi-Fi space for so long. So looks like based on the chat and questions, it looks like I'm in the same boat as everybody else, so I don't feel too bad. But yeah, lots still to learn and figure out here. But this was really helpful.
Yeah, same for me. Kevin, thank you so much for this. Really appreciate it. And everybody in the chat, thank you so much for playing along and asking lots of great questions. Tons of great discussion there. It always feels like we have like 2 webinars happening at the same time with these, and I just really appreciate that. These are a lot of fun.
Thank you, and Kevin, dude, thank you so much for your time, and thank you. Say also huge thanks to your team. Like it's been great working with them. I know our guys love working with your team as well. And dude, it's out the door, and next week people can actually use your production database and our production product linked together. So thank you so much for the partnership.
Absolutely, pleasure to be here. Nice meeting many of you through chat. Again, it's exciting times for the Wi-Fi industry, and
It really is. It
very
really
exciting
is.
times. And I think part of it also is, it's companies like Hamina, like it's all these people that are, the industry and the alliance are working on certain little things, but really we're just enabling all these great innovations from companies like yours. So it's always a pleasure to be out here and speaking with you.
Cheers, and yeah, let's keep in touch and face to face. At least I'll see you in Phoenix. That's right.
You're gonna miss me. I'm gonna be in Tokyo. We will have some people in Phoenix.
When are you gonna be in Tokyo?
During WLPC Phoenix. So our member meeting overlaps at WLPC, and I really wanted to get out there, but if Keith lets me, I will definitely find an opportunity to show up at one of the upcoming WLPCs.
Sounds great, man. Sounds great.
Usually I have to have you beg for me, so Keith will let me in the door.
And actually, I'll be in Texas the week before WLPC as well. So if you happen to be around.
Okay. Well, we may need to get together then.
Yes, sir. Yes, sir. Beers on me.
Thanks, everyone.
Cheers.